Hi, fourth grade. Today we're going to continue reviewing for our math test on Tuesday. I'm going to go over question 6 first. You notice this question is adding fractions, but something special about the fractions are that the denominators are not the same. That means we need to change our denominators. So I have to decide if I can change them both to 100 or if I can change them both to 10. So let's look at it. I have 30 over 100. I'm going to rewrite it so it's easier for me to see it. And I'm going to rewrite my 5 over 10. I like mine vertically. So I know that 10 can become 100. How do I do that? So I'm going to say, I know that 10 times 10 equals 100. And our rule is whatever you do to one part of the fraction, you have to do to the other part of a fraction. So I have to take my 10 again and multiply it to my numerator. 5 times 10 is 50. Oh, I can make 30 over 100 add to 50 over 100. I can do that. So let's go ahead and add 30 plus 50. And what do I get? I get 80. My denominator stays the same since they're both 100. And I write 100. Now to challenge you, you should try to simplify 80 over 100. So I could do a couple different things. I know they're both even. I could divide them by 2. But I also noticed that they both have zeros in them. A zero tells me something about a number. It tells me that there might be a 10 in it. So can I divide 80 by 10? And can I divide 100 by 10? Yes, I can. So again, whatever you do to the top, you do to the bottom. So I'm going to divide 80 by 10, 100 by 10, and I get 8 over 10. I made it a lot smaller, but can I make it even smaller? Absolutely, they're both even. So when they're both even, I know I can divide by 2. So I'm going to divide by 2 each of them, and I get 4 over 5, 4/5. And that is a way to simplify your problem. Now, you should always try and challenge yourself to do that because it's going to be an expectation as you get older into 5th grade, 6th grade, and on. Now, I had mentioned maybe I can do it into tenths. So should we try it again? Let's do 30 over 100 plus 5 tenths and see if I can make them both into tenths. So I started out with 30 over 100 and 5 over 10. Since 5 over 10 is already 5 over 10, I don't need to change that one. Is there any way to make 100 into 10? Well, we just had a hint before. I see that there is, I know that 10 can go into each of them because 3 times 10 is 30 and 10 times 10 is 100. So I'm going to divide each by 10. And I get 3 over 10. Can I add 3 tenths and 5 tenths? Absolutely. So when I add 3 plus 5, my numerators, I get 8. My denominator stays the same. 8 over 10 is 8 tenths. Can I simplify it? I can because they're both even. Divide each one by 2, and I get 4 over 5, 4/5. You should notice that my number simplified is the same for both ways, for both finding the denominators in both ways. There's another problem you should try. It is 9b, and do the same thing. See if you can make them both 100, and maybe to challenge yourself, see if you can make them both 10. Okay? When you're ready, we're going to go on to question number 10 and the line plot. Now this is the hardest part, I would say. And line plots have lots of things that we need to do. So we have to have a title. We have to label our x's. We have to put all our x's in, and we have to make sure we label everything correctly. So let's look at our information first. The students stacked up the books in their desks and measured the stack to the nearest half centimeter. And these are what we got: 6.5, 8.5, 7, 6.5, 7.5, 8, 7, and etc. And I want to make a line plot number for letter A. So I'm going to look for my smallest number. 6.5, 8.5, 7, 6. Looks like my littlest one is 6.5. So maybe I'm going to label my first number 6.5. It might be a good option. And then I'm going to count how many 6.5s that I have. Each time I find one, I'm going to put an X over 6.5 and I'm going to cross it out. So I have 1 6.5. I'm going to go along. Oh, there's another 6.5. I'm going to keep going along. Oh, there's another one. One more. I have 4 6.5s. So I'm going to go to my next number. I see a 7. So I'm going to make that my next one. And how many 7s do I have? There's 1 7, so I need 1 X. There's another 7. There's another X. I don't see any more. So I'm going to go on to my next number. After 7, and it looks like I'm counting by halves, and I also measured to the nearest half centimeter, so it should be halves. After 7 comes 7 1/2. So I'm going to write it down, and I'm going to find my 7 halves. Here's my first one, so I'm going to mark an X for that one. Keep going. Oh, there's one more. I can mark an X for that one. After 7.5, I know that the next number is 8. Let's see if I find any 8s. I do. I have one. Here's 1 8. Here's 2 8s. Very good. And then I have one more blank. I also have one more number. 8 1/2. I have one of them, so I'm going to have 1 X. So now you've done most of part A. The thing you haven't completed is a title and a label. So the title has to be about the whole graph. So what is our graph talking about? It says a student stacked up the books in their desks and measured the stack to the nearest half centimeter. So this should be about book stacks. So I'm going to write for my title, book stacks. All right. Then I need a label. What do those numbers represent? They represent the height or how tall that book stack is in centimeters. So I don't have a lot of room here, so we might go down a little bit further. I'll write it below. I'm going to put height because it's how tall in centimeters, cm. If you can give me units, that's great. That's even better. Now, it's going to ask us some questions about these. Let me go ahead and change my marker back to black. Sorry. I'm going to ask myself this question for B, as we just did A. What is the height of the tallest stack? So this is kind of crazy. And what's the height of the shortest stack? What is the difference in height between the tallest and the shortest stack? So again, it said they stacked up books in their desks and measured the stack to the nearest half centimeter. Okay. Which stack is the tallest? So do we look at the biggest number or the biggest number of X's? That's something you have to ask yourself. It depends what the question is asking. What's the height of the tallest stack? We had 8.5 centimeters tall. That's pretty tall. And how many of them did we have? We had one of them. So 8.5 is our height. Now, what's the shortest stack? We have 6.5. And even though there's 4 different students who had that, it's still the smallest of the stacks. So I'm going to write 6 1/2. Now I want to know the difference between the tallest and the shortest. So I'm going to write a number model with an unknown. So I'm going to write 8.5 for my tallest. I'm going to subtract 6.5. And my unknown, I'm going to use H for height. You can use any letter you want as long as it makes sense. And then I'm going to do the math. 8 1/2 minus 6 1/2. I can subtract my halves and get 0 halves. 8 minus 6 is 2. Now, do I need to write 0 halves when I write my answer? No, because it's a whole number, and you don't need the fraction when it's 0. So my answer is 2. But you must add your units. 2 what? 2 pizzas? No, we're asking about the height in centimeters, so the answer is 2 centimeters. Now, that's kind of a lot of work for one problem, but you will have a problem just like this on your test, so make sure you look it over and be prepared. Now, just for a bonus, if you still have time, I've brought one more problem that I've seen cause some trouble with kids. So the judo template is that blue template, and you can use to draw this, and it asks you to write an equation to show your answer. Now, there's 2 different ways to do this equation. You can do it with the shapes, and you can do it with numbers. Let's see if we can do both. It says I have this triangle that equals 1/3. I want it to equal, I'm looking for the whole. So how do I decide what the whole is? I look at my denominator. My denominator is 3. So how do I get the whole number from thirds? So to get any whole number, and you know the denominator, you put the same thing on the numerator. How do we know that? Because this says 3 divided by 3 equals 1, and that's our whole. So I'm trying to get from my 1/3, one little triangle, to 3/3. So I know that I want 1/3. That's my 1/3. And I want to add it to something to get to 3/3. Well, I know when I'm thinking to myself, 1/3 plus 1/3 plus 1/3 equals 3/3. I'm thinking in unit fractions. So 1/3 and the next triangle equals 1/3. Another triangle. I know that my fractions equal 3/3, and I know my 3 individual little triangles. Well, what kind of shape do we get when we do that? Let's see. I'm going to draw them like this. What shape is that? It's a trapezoid, and a trapezoid equals 3/3. So I'm asking you to draw it and to write it in numbers. You're going to have a question like this on your test too. So I hope this has helped you and that you have a better understanding of how to solve these problems. Good luck on your test tomorrow.